So next is factor of safety. What is factor of safety? The factor of safety is required to bring structure from state of collapse to usable state. For example, if we design a structure like that, the Pu applied load is equal to Pn, the nominal capacity. In that case, if somehow the applied load increases the Pu value, so in that case our structure will collapse. So there may be some uncertainty in the applied load. So if in any case the load increases the nominal strength, then the structure will collapse. Or otherwise, if the nominal strength is less, there is some uncertainty or there is some flaw during the construction, and the strength of the section is less than as expected. So in that case, again, if the load reaches up to Pu, the structure will collapse. So to counter that, we need to apply some factor of safety. Either increase this Pu, this P, by multiplying it with the factor of safety, or reduce this Pn by dividing it with the factor of safety. So both approaches. This is LRFD approach and this is ASD approach. So these factor of safety are actually applied to bring our structure to usable state from the state of collapse or unstable state. Other than this, it also covers for the other factors like uncertainties in applied load. For example, if we have designed a classroom for 200 people, but there is a possibility that more students or more people can gather in that classroom. For example, 300, 400 students can gather in that classroom. So if we have not applied the factor of safety, our structure will collapse. So the deflection should be small at service loads. So we also apply the factor of safety to keep our deflection within the allowable limits at service loads. It also covers the uncertainty in material strength. So material strength can vary inside the member, as well as if we have fabricated the different structural member in the factory, so their strength may vary a little bit. For example, if we test under tension, their strength will be somewhat different. For example, its strength is 420, its strength is 415, and its strength is 425. So there is small variation in strength. So mostly we use the average value. So we will report its strength 420. But if the strength is 415, what will happen? So the structure will fail at the service load. So to counter this, we need to apply the factor of safety. So instead of this average, we reduce it by, for example, 0.9 to bring it to some lower value. So it also covers in part poor workmanship. So during erection of the structure, for example, in case of column, we have this condition that there is no bending moment acting on this section. But if during construction it is not perfectly vertical, it is somewhat inclined. So in that case, due to eccentricity of load, this eccentricity, a bending moment will generate in that section. So to account for that unforeseen circumstances, we need to add some factor of safety. So it also covers unexpected behavior in case the theory is not fully developed. Most of the time or sometime the applied loads by multiplying or by applying the factor of